Hey everyone, my name is Andrew Chris, and I'm going to talk about my ideas for the Nutcracker project. So what we want to do is apply design for manufacturing and assembly principles to streamline the design of the Nutcracker. We want to spend less than $150 on each one, and we want to have a maximum of 20% of the cost outsourced. I'm going to talk about a few of the parts, not all of them, but some of the things that stuck out to me. First being the plates. The plates are a ½ inch thick, and they're stainless steel plate. So this requires water jet cutting, which is very expensive. $2,000 to cut, one plate. Um, it's it's cost prohibitive, and we also have different hole sizes. So this center hole and this little side hole for the bearings are different sizes, and I just wonder if we can standardize that and maybe make them the same size. The drive shaft. The thing with this that stuck out to me was we're taking 2-inch bar stock and we're reducing it to 1 inch for most of the length. This flange here is 1.5 inches in diameter, but that's such a small portion of the length. Most of it is only 1 inch. So we're actually removing and wasting most of the stock material by reducing that so much. So I wonder if we can, maybe get rid of that flange somehow. And the brackets. So these brackets are solid steel. They're just chunks of steel, very heavy. The two brackets together weigh 85 pounds, and they require water jet cutting because of how thick they are. And that costs $3,200, I think, for two sets of these. So just for two nutcrackers, $3,200 to water jet cut those. And these also have tight tolerances, I noticed. The 3 to 4 decimal places were given on the dimensions, and I can see for some dimensions how that might be necessary, but others, I really don't think you need that much accuracy. Especially the four decimal places. I don't think you need that here. So for the assembly, like I said, it's very heavy. You're going to need special equipment, definitely steel-toed shoes. We're going to have back injuries, if we have operators lifting up these parts or these assemblies. We have to take the time to rig them if we're going to lift them with a crane or some other way. It's going to add to the cycle time. And just a general thing on the assembly is that the whole thing has to be stood up on its side to tighten the corner screws. So you need to get a wrench or a ratchet on the screw head and a wrench on the nut on the back, and you can only do that by having it stand up on its side. So you have a tipping hazard there, and also it's hard to lift that up. It's well over 100 pounds. So things that I'm going to look at for improvement. Can we have a lighter material to reduce the weight? Is there anything we can standardize? Maybe have common sizes, processes. Can we eliminate the water jet cutting? I don't think it's possible to get the cost under $150 if we still have the water jet cutting. That's just way too expensive. And assembly. Can we reduce the part count? That's basic DFMA principle right there, is reducing part count. So I'm going to go through my parts that I designed now. This first one is the housing, and at first glance it looks a lot like the brackets that I just talked about. But this is actually made of aluminum 6061, which has 360% machinability, okay, compared to the 45% of the stainless steel. So this is much softer, much easier, much quicker to machine, less tool wear. The outer dimensions 4.95 inches on a side here and 2.35 inches deep. I don't see why the Nutcracker needs to be any bigger than that, and I'll get into that with the wheel coming up. But this can be made from 5-inch bar stock. So if we went with 5-inch outer dimensions, then we would need maybe 5.5-inch bar stock, which is considerably more expensive. So we can just make it 4.95 inches. It's no big deal. But because of the small size and the light material, this part is only 2.65 pounds, so very light compared to the original brackets. This back plate which you can see this thin section here. It's the entire back side is 1/10 of an inch thick. It doesn't need to be any thicker than that, I don't think. There's 2 holes for the bearings, 1 1/8 inch. There's one right here, and there's one back behind here. It's concentric with this arc. And then these holes in the corner are actually drilled and tapped. Okay, so these are not through holes. You don't need to put a nut on the other side. You just screw the screws in. Okay, the wheel is also made of the aluminum, outer diameter 3 inches. You can see the slots are still like 1 inch deep. So the wheel doesn't need to be so big. 3 inches, seems to do fine. And you result in this X shape by doing that. You can use 3.5 inch bar stock, which, as it turns out, is less expensive than 3 1/4 inch bar stock. So that's why I chose that. This is 0.68 pounds. It has this 1/8 inch square key, which I'll get into with the drive shaft next. And these are all filleted here, 0.2 inch fillets, just to make the machining path smooth instead of the sharp corners of the previous design. And there's no rhyme or reason to the 0.2 inches. I just tried some different values, and that looked like it worked pretty well, so I stuck with that. The drive shaft is made of 316 stainless steel, very similar to 304, but it has increased corrosion resistance to salt, which I figured, if nuts are going to be going through this, nuts can be salty, and it might be nice to have that extra corrosion resistance. May result in the parts lasting longer. And the 316 still fell within the budget, so that's not a concern, even though it's a little more expensive than the 304. But the outer diameter of this is 1/2 inch. It's made from 3/4 inch bar stock. It weighs 0.15 pounds. There's this 1/8 inch keyway, and that takes the place of the flange. So this will stop the wheel from sliding further this way along the shaft, and it will also stop the wheel from rotating around the shaft. And previously we relied on friction, press fit to do that, but now we have an actual mechanical barrier that will take care of that. And also this can be machined very quickly, just a simple slot here. And this square end is 1/4 inch on the side. The crusher, not much to say. It's also 316, larger diameter 0.73 inches, smaller diameter 3/8 for the bearing, 3/4 inch bar stock, which happens to be the same as the drive shaft, so that's nice there. Standardized stock material, and it's 0.23 pounds. The cover is made of 316 stainless steel sheet, same size as the housing, but it's 0.12 inches thick, 4x8 foot sheet. It has the 1 1/8 inch holes for the bearings like the housing does, and it has the through holes for the screws in the corner. So for the assembly process, it is gravity assisted. So after you insert the bearings in the housing, you can actually lay the housing down on its backside, and you can insert the drive shaft, the crusher, and the wheel. Then you place the cover on top. You insert the bearings in the cover over the shaft and the crusher. Then you insert and tighten the corner screws. And the only tools you need are a hex wrench for the corner screws, and you might need a rubber mallet to pound the bearings in, because those are press fit. So the savings, I calculated the materials, including the purchase parts, to come out to $82.86 for a savings of $21.70 and 22 cents. So great savings of material there. Labor comes out to $42.33. We have a savings of $8.17. Not nearly as good, but if you think about it, we're taking that labor that was outsourced before, the water jet cutting, and we're doing that in-house now. So we are providing that labor. So the only reason why labor hasn't gone up is because we're using softer materials that are easier, quicker to machine, and we're using our stock materials more efficiently. We're not, machining a 2 inch bar down to 1 inch. And the weight 4.5 pounds is the weight of the full assembly. So I don't know the weight of the full assembly previously, but it must be well over 100 pounds. So we have a great savings in weight there. Some questions that came up for the customer. What kind of nut is going to be going through this? Different nuts are different sizes. Maybe there need to be different configurations of this to accommodate different sizes. Maybe you need an adjustable crusher. It can move horizontally to accommodate different sizes of nuts or something like that. And the other thing is there a desired finish or coating? Obviously this is going to be a higher cost if you want to add a coating or a special finish. But if it makes the product last longer, it might be worth it to them. And being in the food processing industry, they might have certain requirements for finishes that they want to meet. So just some things to talk about as you're consulting with the customer on what they need. So anyway, that's what I came up with. Thanks for watching, and I hope you enjoyed it.